All right, guys, as you can see, I'm in a little bit of different area. I normally am. I'm trying to get some of these videos busted out, but I've been sick past 2, maybe 3 weeks. I was bedridden for almost a whole week. So I'm trying to get back, get everything done. We're talking about the Sam's rewiring project, which I've had some videos before I got sick that I'm trying to kind of link together for you to get it out. But I really apologize. Some of the videos are going to be a little bit sporadic going out until I can get all this stuff done. I've also got a video of the NDRL banquet that I'm real excited to send out. I just need to have the time to edit it. Also the t-shirts, we're still waiting on the t-shirt guy. We submitted that stuff a month and a half ago. Chris just actually texted him. We haven't heard back from him. Hopefully that's going to be soon. We'll try to get those out. As soon as we get them, we'll send them out. Today's video, we're going to talk about wiring diagrams, how I do them and with what software. We're going to talk about the tools that I use, the type of connectors, the type of wire, everything like that. We're also going to go over an amp chart wiring diagram, like a rating. That's going to give you an idea how I decide what size wire I need for what circuit. Everything that we're going to talk about today, I'm going to attempt to add as much stuff in the description with links to where you can buy it if you like something or interested in getting something for yourself. All that'll be in the description as best as I can. I may have to go back and keep adding stuff. Enjoy the video and make sure you like and subscribe, and I hope you enjoy. All right, so the first thing I always do, I like to start out with, after everything's been removed and I've got everything mounted where it's supposed to be, is start making a diagram. This will ensure that you think about each circuit as a group and to make sure that you run the wires properly to make sure there's no interference. I like to try to make sure all my high amperage stuff stays with the high amperage stuff. I like to make sure the coil is by itself, and I like to make sure any sensors by themselves, so there's no interference, no chance of interference in the future. So with this one, the first thing I do is I open up, I use a program called Easy EDA. It's an easy diagram program. It's free. It's pretty intuitive to use. And the first thing I always do is I start drawing the main distribution panel and any of the main units, such as your CDI box, any race pack, you know, etc., etc. I draw those in first. So the first one I got here is the MSD7AL3 with all its pins, and each pin is numbered, as well as this is our arc relay board right here with all the numbered pins and I try to draw them in such a way that it's similar to what the unit looks like. It's kind of hard to do sometimes, but you know, just to make sure that it looks a little bit better when it's printed out. So once I get those done, then I go ahead and draw a battery in, disconnect any of the main fuses go into these boards, and then I start adding all the individual circuits. So this one right here is the trans brake, oil accumulator, line lock switch, trans brake switch, etc., etc. And then I will draw those circuits into the diagram to where they're going to go. One thing I make sure that I do is where they're going to go through hole or through the firewall or the floor. This particular unit's going to get 3 holes in the floor, one for the main wiring through here, and then one for the coil and one for the crank sensor. If I had more sensors, all the sensors would go through in line with that. I draw out all my grounds. I number the grounds so that to give me an idea how many grounds there are, but also so each ground is actually a point. So to give an example of that is all 4 of these units right here, the line lock, gas pump, electric fan, water pump, is all going to be to 1 ground. It's going to show ground 3, etc., etc. You kind of get the gist of this. I do these for every car that I do. For one, it gives me a good game plan going into actual wiring so I don't mess up lengths of wire and such, but it also makes sure that I'm really aggressively looking at where all the wires are going before I run them, just so that there's no chance in the future that I end up with you know, a signal wire next to the coil, for instance, which would be the worst case scenario, particularly with this car. All right, so after this is done, when I'm wiring the car itself, I will actually go in here and change each individual circuit wire to whatever color the wire is. So that one's purple now, and you can see now that line has changed to the electric fan to be a magenta. Every circuit that I do, I come in here and change to make sure that everything's updated. The best part about this is once all this is done, and it's a good idea to do anyway, because to make sure you're doing everything right, but once it's done, I can get this printed out in a large sheet and laminated, and then Sam gets to take this in his trailer and have it to reference if he ever needed to add to something or had a question about something. One thing I do also is I label each one of the ends of the wire. I use the wire that has the labels built in. More than likely, especially nowadays, it's harder to get, I use a label maker with either a flag or a self-laminating sticker, and I will label them to where it's going to be either an acronym or the circuit. And that's, for instance, like say this TAC circuit right here off the MSD, the 7AL. You see right now it's labeled 7B. If we go to where it actually ends up, it's labeled 7B as well. So B is going to be for the coil or the CDI box. So all these circuits will be B. So whenever you're later if you have to adjust anything, you'll see at the end of the wire, this one's going to the coil. It just makes things a little bit more intuitive and makes a lot more sense. All right, so I hope that helps. The next thing up is to start running some wire. All right, guys, here is a accumulation of stuff I've had over the years and the stuff we're going to use on Sam's car. The first thing we're going to talk about is wire selection, and it's really important to get good high quality wire, either TXL or GXL style wire. I personally get mine through the Wire Barn or Amazon. There's several different ways. I used to be able to get it with where the name of the circuit was on the wire, but it's hard to find that anymore, so we'll talk about what I do now. But the big thing about this wire is you don't want to get this wire right here is household grade wire. It's solid core. Do not use this stuff in automotive use. Or this stuff right here, which is also household wire. It doesn't bend well. It'd work at a pinch, but you really don't want to. Lastly, stay away from automotive amplifier wire or anything they call like that. This audio pipe is junk, and the strands will literally just pull out on you, and just stay away from that stuff. The high quality stuff is this, and that's a little cross section of it. It's really high quality. It bends easy. As well as the heavy gauge stuff. This is actually welding wire that I use. It's high temperature. It's got a nice jacket on it to protect it. So stay with this. And later in the video, I will explain wire gauges and how many amps you can put through them per the feet. And I'll show you a chart and link to the chart. The next thing you need to consider is your fuses in order to protect the wire. So the fuses protect the wire, not the component. So you want to make sure that you fuse correctly to the gauge wire that you're running in that circuit. So also I like to make sure that I use good quality fuse holders. If this needs to be like a single circuit, I've got several types here and different gauges, and obviously some fuses that go along with them. Also, here is a maxi fuse holder. This is one we're going to use in Sam's car. It's a mountable style, and you got to make sure you use ferrules with these, and I'll explain that in a minute. Here's the connectors that I recommend using. I get these through Amazon as well. They're relatively cheap, but they're heat shrinkable. So these are a butt style connector. You put 2 wires in, clamp them down with a crimp tool, which I'll explain a little later, and then you heat shrink these down. It means that there's no corrosion inside that wire because it's all sealed from the environment. What I don't like anybody to use, and I don't personally use them, is this style connector.
These are old style connectors that when you crimp them, they just make a mess, and you can never get them crimped correctly. They always want to come off. So stay away from these little kits. They're junk. And also, if this kit comes with this heat shrink here, it's junk as well. It's really thin, and as soon as you heat it up to shrink it, it'll tear or something. So I stay away from this type of stuff. But this is a kit that I'd found in my stuff, and I probably just need to throw it away because it'll never be used. So what I recommend you do when you're first starting out is just get one of these big kits. And then whenever you find out what you're using the most of, like I have some empty slots there, then replenish it with a large kit of just that style connector. So, and it's relatively cheap. I think this is a 200 piece. I think this was like $28 or something like that. So they're relatively inexpensive, and they're the proper connector to use. Here on the last video, I showed you me mounting the distribution panel to that black plastic, which I got from Menards, I believe, in a big 4x8 sheet, and I've been using that for a couple of years now. And here are the grommets that I use to the floor to mount the piece of plastic. These are fantastic. They're really cheap. I think they're like $5. Next up is going to be how you affix the wire to the chassis or the body. Again, I buy these bigger kits, and then I replace them with the individuals that I use the most. These are really nice, high quality hose clamps. You can use them on brake lines. You can use them on big wire. You can use them on small wire bundles. So there's that. Again, get these kits and then buy what you use the most of. Next up here is shrink tubing. This is the shrink tubing I just got from a new company that I do like. It's really thick shrink tubing, and they call it 2-to-1. So it'll be half the size that this is before you shrink it. So this is really good high quality stuff. These here are a little bit lower quality, but I've used them before, and they're pretty good as well. And they're cut to the right size if you're going to use non-insulated connectors. And I'll show those in just a second. Also, here's some blacks. These are really high quality, even though they're said made in China on there. These are actually pretty high quality stuff as well. They're nice and thick. I believe all this stuff can be had on Amazon. Probably going back to the connectors a little bit, but here is an uninsulated butt connector. And these will be crimped down with a tool I'll show in a minute. And then you'll heat shrink over top of this. I usually do 2 ink shrinks, and I'll show that being done as well. Lastly is these are called ferrules, and if you're going to tie into a unit like this, you don't want to put just bare wire in there. You want to ferrule it. It just keeps it more secure. So that's what these are for, and I use them whenever I use a connector like that. All right. Wire protection. I always use this stuff. This is stuff you can get off of Amazon. It's high temperature and it's split loom. The only thing you have to do is when you cut it is you put a little bit of heat to the ends, and it keeps it from fraying. This stuff I use on everything. There's some high temperature stuff we're gonna buy for this project as well. I want to try it out. But this is the old style. There's nothing wrong with it. It's just corrugated split loom. It's good stuff. I just don't like the look of it. I prefer this style. Lastly is zip ties. We have tons of them. I got big bags of them in here. This is just some of the smaller stuff. Make sure when you use a zip tie that you don't use just a pair of side cutters like this, because you end up with a dirty edge like that. So what you want to use with those is right here, and I'll explain it in the tool again, but use a pair of snips like that. That's nice and smooth. Okay. All right, so we'll slide all this over and we'll show you some of the tools that I'm going to be using. I'm going to show you a few of the tools that I use that are wiring specific tools. Tools that are beyond the tools that you would just use in your toolbox, screwdrivers, wrenches and ratchets and things like that. These are wiring specific style tools. So the first up with just the hand tools, these are a pair of side cutters. These are the ones that I've just always used. They're not any name brand, but you know, they're good side cutters. These are with the tool I showed a second ago. These are called flush cuts. Definitely use a pair of those whenever you are doing zip ties. It makes a cleaner job. And then I really recommend, especially with automotive work, to get some of these style pliers for stripping and crimping. The reason I like these the most is the crimp is on the outside there, okay? So you're not trying to crimp inside here, and they work really good in tight spots, and these are actually a pair of snap-ons. I know that other tool makers make them, but definitely get this style crimper and stripper. Next up is just gonna be a little butane torch, a little crack torch. I use this to do all my heat shrink. A basic multimeter. This happens to be one from AutoZone from a lot of years ago. I've actually got some Flukes. I've got some more expensive ones. They all read the same. Just get you a high quality one. Stay away from the cheap ones from Harbor Freight that only have like the little voltmeter. These are a lot more accurate. Back to the crimping, which is a little bit more expensive. When you're crimping big wire, I use this. You can either put the crimp in there and then hit it with a hammer. I tend to, if I have the ability to, take it over to the press and I just press it down. So depending on what I'm doing, they both styles work. Next up is a wire label maker. This is a Brady. They come with different cartridges. You can have just like a normal label maker and you just fold it over, or you can have, this is called self-laminating, and it goes around the wire and it basically, you know, makes the label itself water resistant and whatnot. This is the style that I like using. These kits are around 200 bucks and they're totally worth the money. If you're going to have to do any type of soldering, I really recommend these Power Pro butane torches. I've got 3 or 4 of these things and they've lasted great, and they're fantastic. One of them, I've actually got the tip off of it to where I can use it as a butane torch if I needed to, and this one's set up for solder. You can also get, I think called Hakos. They're wired units. They're really good as well. Stay away from cheap soldering irons though. They just give you fits and problems. I would definitely get you a nice one. Power Pro makes, for me, one of the best I've used. Lastly, into the more advanced electrical tools that I have, this is a Power Probe. It's basically I'm not exactly sure what they call it, honestly. It's a master combo kit, but it's got a unit that I use for circuit testing, and these are the best things for, I don't even use a multimeter anymore. I just use this. You don't have to buy this big a unit. This one is really good for short detection and fault detection, but mainly 9 times out of 10 I'm just using the Power Probe unit itself, and they sell it just by itself. You don't have to get the rest of this stuff. These are fantastic, well worth the money. All right, so these are the tools I use. Comment down below if there's a tool that you use that's not here, or maybe I'll have to add it to the list of things I use in the future. But next up is going to be talking about wire gauge size and how you determine all that.
All right, let's talk about wire sizing and fusing. Really the gauge of wire is going to be determined by how many amps that circuit is going to draw, the length of that wire, and the voltage that you're operating on. Almost all standard race cars are going to run off of 12 or 16 volt. 16 volt you can get away with a little bit smaller wire because it's a little higher voltage, but I don't generally care when I'm wiring a car whether it's 16 or 12. I just base everything off 12 volt. The difference there isn't enough for me to justify changing the wire size. A good example of what we're going to talk about is we'll just wire a simple radiator fan, electric fan. Generally those will have a rating on when you purchase it, or you'll need to run the fan and do an amp test on it, but they're going to be less than 15 amps during operation. So the next thing you need to figure out for that circuit would be how long that wire is going to be. Let's just say that the wire is going to be less than 10 feet to the distribution panel. That will give you all the information you need to determine your gauge size. Right here is a chart. If we use the 10 feet at the bottom, so 7 to 10 feet there, and we go to the 0 to 20 amps, it's showing that we need a 12 gauge wire. That's what I'll use as a 12 gauge wire for that circuit. and then I'll do every circuit that way. Generally, it gets really expensive if you try to get every thickness of wire in every color. I like to do different colors to make the wiring a cleaner job, and it's easier to trace things down. So what I generally do is I buy bulk of 12 gauge and 10 gauge for all my circuits, even if it's a 5 amp circuit. Sometimes I'll use that 12 gauge. I do stock some 18 gauge, just not as much. Mainly I use the 18 gauge for sensors, but I also stock some 22 gauge also for brace pack sensors, stuff like that, or jumpers for those sensors. So that's kind of how I purchase wire. Is I try to buy it in bulk. I can't buy the whole spectrum from 12, 14, 16, 18 gauge, so I generally stick to 12 and 10 and for any of my circuits that have amperage, and then 18 or 22 for all the sensor circuits. Then the other two you have to think about is your starter wire, which is going to be heavy aught, maybe double aught or 2 gauge, depending on the length of run. Most batteries in a race car are going to be in the very back, so it's going to be a really long run to your starter. You're probably going to need some really heavy wire for that. Also, you need heavy wire for the negative to your chassis and from your chassis to your motor, just to be sure everything's grounded. And you also need to bond the body to the chassis as well. That doesn't have to be as thick, but it needs to be at least 10 gauge wire, maybe 8. That being said, the other circuit you need to have some really heavy gauge wire on that I usually stock is your alternator. Most race alternators, my truck is only like a 40 amp alternator, so I really don't need a whole lot. I could get away with 10 gauge, no problem. Most automotive alternators, the ones you buy at AutoZone, for instance, are going to be roughly 80 to 120 amps. Those I like running at least 8 gauge wire for, maybe 6 if it's 120. All that's going to be based off this chart, and I'm hoping that it gives you a pretty good idea of the best way of, it's not the best way, I shouldn't say, because there's actual calculators you can get down to very nitty gritty. But this chart is what I use to determine my gauge sizes. Let's talk about fusing a little bit. So you never want to fuse for instance, I use this chart for fusing as well. That 12 gauge wire I ran to that cooling fan. I know the fan has a 15 amp operating, but it probably needs to be fused to 20 amps because you have a lot of inrush current. The wire itself can handle 20 amps, so it's not a big deal. But what you don't want to do is put a 25 amp on a 12 gauge circuit that has a length of, plus 10 feet, because then you can overcurrent that wire, and it's a possibility for a fire there. So you always want to fuse for the lowest common denominator. So if your circuit is a 10 amp circuit, but you're running 12 gauge wire because, like I mentioned earlier, it's cheaper for me to stock that size wire, then obviously the wire can handle 20 amps, but if your item is only 5 or 10 amps, that's what you'd fuse for. So that's how I base all my fusing. I also do something that a lot of guys don't do, and I don't know why, is the fuse I fuse from the alternator to the battery. A lot of guys just run it direct. One thing you have to worry about with race cars is the very back kill switch. The alternator has to be on the other side of the kill switch from your accessories, so that when you kill the battery, there's no power to your distribution panel, so it cuts everything off. So you have to run that wire all the way back to the battery. You can't run that wire, the alternator, to the starter, for instance, because a lot of guys run it that way, because it will not shut your car off when you hit the kill switch. So you have to run that all the way back to the battery. That's a lot of wire that something can abrase and cut open enough to where it could get some chassis ground and then cause a fire. So I always ground it as close to the battery as I can. So in Sam's car, for instance, there's going to be 3 fuses in the back. There's one for the main distribution panel, one for the MSD box, because that's how they want you to wire it, directly to the battery. That's a capacitive discharge situation, the reason they went up all the way back there. And then lastly, there'll be a fuse for the alternator. From there, you get to the distribution panel, where there'll be all the fuses on that ARC module, and all of them are set to 30 amps. So I need to go through there and change each one of those fuses for that circuit size. Most of them will go to 20 amp or 15 amp, for instance. And then there's a couple, in this situation we had to use a couple inline fuses. I don't particularly care to use them that way, but sometimes you don't have an option and you have to run them inline. So obviously you just use it for what you need there. Hopefully if you follow the amp chart, you make sure that everything is grounded properly so that you don't have excessive amp draw, and you fuse everything properly, you'll have no issues in the future. All right, so in the next part 3, the car is already done. While I was sick, I had to go out there and just put a half hour in just to get it done, because it has to be picked up. So I didn't get as much video as I wanted. So what I'm gonna do is I'm gonna just lay a simple circuit on a bench and show you how I terminate the wires, how I sheathe them, and then make a small circuit on the bench and go over it. So it'll be part 3. And that'll give you a little bit better idea how I use the tools, the wires, the connectors, and a simple circuit, so that, and I'll even use the gauge chart to explain how that's gonna work. All right, well, I appreciate you watching. Make sure you comment down there if I've said anything wrong, or if you have any good ideas of what I should do better. I don't mind constructive criticism at all, and I hope you enjoyed the video. Make sure you like and subscribe, and thank you.